Alright, in this video we are going to talk about dividing polynomials, and we're going to do so using long division. So to start out, I'm going to remind you of how long division works just with numbers, and then we'll look at it in terms of polynomials. So if I want to divide 47,321 by 8, I'm going to write it like this, 47,321. And remember, what you do is you look and say, alright, can 8 go into that number? And if not, then I need to take the next number with it, right? And so 8 would go into 47 5 times. 5 times 8 would be 40. We subtract that. We get 7, and then we bring down the next term, right? So it's that figure out how many times that number goes into this, put that up here, multiply down, subtract, and then bring down the next term. And you keep going, right? So 8 goes into 73 9 times. 9 times 8 is 72. And we just repeat this. We subtract. We bring down the next term. 8 goes into 12 one time. 1 times 8 is 8. Subtract. We get 4. We bring down the 1. 8 goes into 41. 5 times. 5 times 8 is 40. We subtract. And we get 1. And then once we are here, remember what you would do is when you first learn this, you would keep it as a remainder. You just say remainder 1. Then you went to saying, okay, well, we can make a decimal point and keep bringing down zeros, and we could get this really long decimal if we wanted to do that. Or what you really have left is 1 out of 8. So what I have is I have 59, 1, 5, and 1/8, right? So that's that over 8. And I'm going to keep that in mind because when we do long division, that's how I'm going to write that. That last term, I'm going to keep that as a fraction, as what I have left over what I'm dividing by. Okay. So, polynomial long division. We are dividing 3x to the 4th minus 12x plus 5 by x plus 2. So we're going to put the x plus 2 on the outside, and on the inside I'm going to write in my polynomial. However, I'm giving you an example where you need to worry about this because you always need to make sure that you have this covered. So our leading term is 3x to the 4th, and then we jump all the way to just a linear term of 12x. If you have missing terms in between, you need to make sure that you write placeholders for that. So I do not have an x cubed term, but I need to write that in. So I'm going to put plus 0x cubed and also plus 0x squared to remind myself of, hey, those are placeholders for my cubic and squared terms, and then I can write minus 12x plus 5. So if you are missing any terms in between your leading term and your constant term, you need to fill those in before you do your division. All right. Then what do? We look at the first term of each polynomial. And we're going to say, what do I need to multiply this by? Basically, how many times does this go into this? All right? Same as with long division with numbers. What do I need to multiply x by to get 3x to the 4th? And that's 3x cubed. And I'm going to write that over top of the cubed term. Okay, so I have a placeholder there. It goes over top of the cubed term. And then I'm going to take that thing, just like long division, I'm going to multiply that down. But when I multiply that down, I'm going to multiply it by both of these terms. Okay? So we are going to do 3x to the 3rd times x plus 2, which is going to give us 3x to the 4th plus 6x to the 3rd. Okay? Multiplying the 3x to the 3rd by both of those things. And then what do? Well, we multiplied, we wrote that down here, this 40, and then every time you subtract, right? Every single time you end up subtracting that thing. So I need to subtract this thing. Here's where you got to be careful, because if you just wrote it like that, I bet you would go ahead and cancel these, but then you would probably look straight down and you would say 0 plus 6. Well, I need to make sure that I'm subtracting this whole thing. So either put this in parentheses or make sure that you change all of your signs down here So if you wanted to, you could say, okay, when I put that minus, I'm just going to change every sign and I can go straight down. Either way, you need to remember that you're subtracting this 6x to the third. So we're going to do 0 minus 6, which is going to give us negative 6x to the third. And then I'm actually going to bring down not only the next term, I'm going to bring down all of what I have left. So plus 0x squared minus 12x and plus 5. Those are all coming down. And then I'm going to repeat the same process. Okay. So the next time what I'm doing is I'm doing what multiplies, what do I need to multiply this x by to get the negative 6x to the third? And that's negative 6x squared. Then I'm going to multiply that down. Negative 6x squared times x is negative 6x to the third. Negative 6x squared times positive 2 is negative 12x squared. And we then subtract. So what I was saying is either put this in parentheses and subtract, or at this point in time, since you're subtracting this, you can go ahead and just change those signs, and then you can just go straight down. Right? So instead of saying, oh, I'm going to put that in parentheses and put a minus out front, whatever the signs those are, these two signs here, I'm going to change those so that then I can go straight down. This is going to be 12x squared. I'm going to bring down my minus 12x, and I'm going to bring down the plus 5. And I'm going to repeat the same process again. What do I multiply x by to get 12x squared? That's plus 12x. And multiply that down. That's going to give me 12x squared plus 24x. And then I'm going to subtract that. So again, if you want to go with this method of just change both signs now, this is minus, this is minus. I can go straight down. That's going to give me negative 36x. And then bring down the plus 5. What do I need to multiply x by in order to get negative 36x? That's minus 36. I multiply that down. Negative 36 times x is negative 36x. Negative 36 times 2 is negative 72. And then we subtract, or we change both signs. Either way you want to look at it. Those cancel. This is 77. Now, once this has a less degree than this. So if I'm dividing by x, once I get to a constant, and that's it. If I'm dividing by an x squared here, it's once I get to my x term, which would be at this step. You're done at that point in time, but that's your remainder. So we can say remainder 77, but what I want you to say is write it as a fraction. I'm going to say plus 77 over what we were dividing by, which was x plus 2. And that is how we do polynomial long division. There's my answer.